So good afternoon, students. And today we will continue with the chapter which we were discussing. We were rediscussing this chapter, matter, okay, matter in our surrounding. And yesterday, can anyone summarize yesterday what we have discussed? Let me see how much you can recall yesterday's class. Anyone, which facts or which concepts yesterday we have discussed? Anyone, can you summarize? What important concept we have discussed yesterday? Okay, Ayush, unmute yourself, Ayush.
Sir, physical state of matter,
Okay, then,
characteristics of matter,
okay,
और state of matter और solid liquid का tabulate difference between हो गया था.
okay, fine.
बस सर इतना ही.
Okay, Ayush, very good. So before beginning today's class, the remaining portion of this chapter, let me have a random question answer feedback session from your side. Yes, Ankur, unmute yourself, Ankur.
Yes, sir.
Ankur, tell me any one difference between solid, liquid, and gas. One difference, minimum, at least one difference between solid, liquid, and gas, Ankur.
Solid are tightly packed.
Okay.
Liquid are liquid are
Liquid are. If solids are tightly packed, liquid definitely, the force of attraction is less.
not really solid.
Okay. Okay,
Yes, sir.
next,
Gas
gas,
are freely move.
freely movable. Good,
Gas are
Ankur,
freely
very
move.
good. Okay, very good, Ankur. Now, Abhinav, unmute yourself, Abhinav. Abhinav, unmute yourself.
Yes, sir.
Abhinav, how can you define latent heat of fusion? How can you define latent heat of fusion?
The amount of heat required to convert 1 kg solid in liquid.
Very good. The amount of the heat required to convert 1 kg of the solid into a liquid. Okay, at that normal atmospheric pressure. Okay, good. Very good. Next. Okay, today I think yes. Yes, Nishant is joining. Okay, no problem. Yes. Ritika, unmute yourself, Ritika.
Yes, sir.
Ritika, define latent heat of vaporization.
So the amount of heat which is required to convert 1 kg of liquid into vapor.
Okay, 1 kg of liquid into vapor. Very good, Ritika. Correct. Yes. Okay, I think now. Yes, Nishant. Yes, I recognized you. Okay, Nishant, we are doing revision of chapter 1. Okay, in this chapter, you were not there during our offline class, so it will be a revision for you all also. Okay, now today we will discuss first the effect of pressure on gases. Okay, that what is the effect of the pressure on the gaseous state of matter. So when the pressure is applied on the gas, the particle come closer. Okay, because the distance between them is reduced and the gas changes into the liquid. That means the force of the attraction will increase and definitely the kinetic energy is going on decreasing. So we can liquefy gases by applying pressure and reducing the temperature. For example, a very good example of this is the compressed solid carbon dioxide gas, which is called the dry ice. And it is used in the refrigerators, definitely. If the pressure is reduced, it changes directly to gas without coming to the liquid state. That is why the solid carbon dioxide is called the dry ice. Okay, so the main thing over here is that by applying the pressure, we can liquefy it. Okay, Now, a very important flow chart which indicate the interconvertible, or we can say the interconversion between the different state of matter. You all can see over here the three different states of the matter. Solid. Solid, if it is converting into liquid, it is called fusion or melting. Liquid, if converted back to solid, it is called solidification. Liquid converting into vapor, that is called vaporization. Okay, that is called vaporization. And if suppose we are saying, you can see this one was hidden. Yes, if we are saying that a gas will be converted back to liquid, the process is called condensation. The process is called condensation. If the gas is converted into solid, if the gas is converted into solid, solid is converted into gas, that is the sublimation. Here the word is missing, student, one thing, that is a resublimation. Okay, it will be resublimation. The solid converting into gas, that is sublimation. Gas converting back to solid, that is resublimation. So this is the interconversion between the different states of matter. So if I ask you, let us have a recapitulation of the definitions which we have covered just now. Can anyone say me what do you mean by condensation? Anyone, what do you mean by condensation? Anyone, what do you mean by condensation? What do you mean by condensation? Anyone? Okay, Ankur raised his hand. Ankur, unmute yourself, Ankur. Ankur, what do you mean by condensation?
The process of conversion of gaseous state into liquid state is called condensation.
Gaseous state to liquid state, condensation. Okay, Ankur. Yes, Nishant, unmute yourself, Nishant. Nishant, unmute
Yes, sir.
yourself. Nishant,
Yes,
can
sir.
you tell me what do you mean by what do you mean by fusion?
Fuse process in which gases fuse in on itself.
Fusion, melting. Melting, Nishant. What is melting?
Melting, a process in which solid melt in liquid form by heating.
Okay, very good. Solid melts into liquid. Okay, fine. Okay, good, Nishant. You can mute yourself. Next question is for Manish. Manish, unmute yourself, Manish. Manish, unmute yourself.
Yes, sir.
Manish, tell me that what is the, you tell me what do you mean by sublimation? What do you mean by sublimation, Manish? What do you mean by sublimation, Manish?
Sublimation means solid state change into gaseous state.
Solid state changes into the gaseous state. Okay, correct. Solid is changing into gaseous, that is sublimation. And Manish, what do you mean by resublimation?
Sir, resublimation.
Resublimation.
Sir, नहीं पता.
You have said solid to gas, that is sublimation. Resublimation, again the reverse, gas to solid. Okay, that is also called deposition. Okay, fine. Okay, Manish. Next, Astuti. Unmute yourself, Astuti.
Yes, sir.
Stuti, can you tell me what do we mean by latent heat of vaporization? Stuti, again you got muted. What do you mean by latent heat of vaporization? Stuti?
Sir,
Unmute yourself, Stuti. I think some network issue from your side. Okay. Okay, fine, no problem. Now, after this, students, we will be coming to the topic of evaporation. Definitely evaporation, the change of the liquid into vapor at any temperature below its boiling point. Okay, that means we are not boiling it, we are not heating it, but directly when the liquid changes into vapor at any temperature, that is called evaporation. And it is a surface phenomenon where the particles from the surface, they gain energy from the surrounding to overcome the force of the attraction and changes to the vapor state. Some of the factors, what are the factors which affect evaporation? Surface area. If the surface area is more, the rate of evaporation will also increase. If the temperature increases, the rate of evaporation also increases. If the humidity decreases, if the humidity decrease, then the rate of evaporation will increase. That means it is inversely proportional. Surface area and rate of evaporation is directly proportional. If one increases, the other also increases. And the temperature is also directly proportional, because when temperature increases, the pressure rate of evaporation also increases. But when humidity increases, rate of evaporation decrease. That is why we have seen that during the rainy season, our clothes dry up late, or we can say they take much time to get dried up. Increase in the wind speed increases the rate of evaporation. Wind speed also increases the rate of evaporation. Okay, so these are some of the important facts. Increase in surface area increases the rate of evaporation. Can you give me any day-to-day life example on this? Okay, no problem, Stuti. Maybe some network issue, no problem. Can you give me one example for this phenomena? The first one, increase in surface area increase the rate of evaporation. Okay, Ayush, very quickly. Ayush is very active during the online classes. Good.
Sir, when we drink tea,
Okay.
thus in a cup, the tea is very hot. When we put in a plate, the surface area is increases and the tea cold faster.
Yes, the tea gets okay. It get cooled down faster. Good, Ayush. Can anyone give the example that increase in temperature increases the rate of evaporation? The second case, increase in temperature increase the rate of evaporation. The second example, anyone? Increase in temperature increases the rate of evaporation. Ritika, my question was that I'm asking from the general phenomena. The factors which affect evaporation, the factors are there on the screen, and I'm asking from day-to-day life some examples regarding this. So can anyone say that increase in the temperature, how does it increases the rate of evaporation? Increase in temperature, how does increases the rate of evaporation?
sir, boiling of water.
Okay, boiling of water. Boiling of water, remember, one thing, Ritika, I stop here because always below the boiling point, we have to say the evaporation, the normal phenomena at any temperature. So can you give some other example? From day to, yes, that is also correct. Correct, yes, you are saying correct. Any other example? Okay, fine, yes, definitely correct. The examples which you have shared, that is also correct. Okay, that is also correct. Now, next, increase in humidity decreases the rate of evaporation. Increase in humidity decrease the rate of evaporation. One that example I've given you, that during the rainy season our clothes get late to dry up. And increase in wind speed increases the rate of evaporation. Okay, if we keep our wetted cloth to dry up when the winds are blowing too high, it dries up quickly. So it indicates that the wind speed increases the rate of evaporation. Okay. Next. Why evaporation, or we are saying evaporation causes cooling? This is a very important fact because we know that evaporation is a surface phenomena. So when a liquid evaporates, the particles of the liquid absorb heat from the surroundings and evaporates. So the surrounding becomes cold. For example, people sprinkle water on the roof or open ground because during evaporation, water absorbs heat, makes a hot surface cool. And during summer, we sweat more because during evaporation, the sweat absorbs heat from our body, making the body cool. And wearing cotton cloth in summer keep us cool because cotton absorbs sweat, and when the sweat evaporates, it absorbs the heat from our surrounding and make the body cool. And that is why students, we say, see, there this is phenomena. Now let me show you that cooler high evaporation because warm air enters, water is sprinkled, there water gain energy from the surrounding and as a result cool the air. This is also the same thing with the desert cooler also. Now student, can you say me that why do we feel cool when we put acetone on our palm? I'm asking you some of the general phenomena. Why do we feel cold when we put acetone on our palm? Why do we feel cold when we put acetone on our palm? These are some of the questions which is related to definitely the mechanism of evaporation. Why do we feel cold when acetone is put on our palm? This was actually the last portion. Okay. Anyone? Okay, Ritika, unmute yourself, Ritika.
Yes, sir.
Ritika, can you tell me why do we feel cold when we put acetone on our palm?
Sir, because acetone is absorbing heat from our palm and gives us cooling effect.
Okay, Ritika, correct, good. Next question. My next question is, why do we prefer to use cotton cloths during summer? Why do we prefer to use cotton cloths during summer? Why do we prefer to use cotton cloths during summer? Anyone? Yes. Why do we prefer to use cotton cloths during summer? Anyone? Okay, Nishan, good. Raised his hand. Unmute yourself, Nishan.
Sir, because cotton cloth absorbs sweat from our body.
Because it absorbs sweat, and definitely when the sweat evaporates, it absorbs the heat from our body, correct? And due to which we feel the cooling effect. Now, my next question, student, why do earthen pots are cooler in summer? Earthen pots are they cool the water quickly during the summer. Why does it happen? Earthen pots. Yes, Ritika, I've seen your answer correct. Anyone regarding the earthen pots? Anyone? Why do water kept in earthen pots get cooled during the summer? Manish, can you answer this question? Manish, can you answer this question?
Yes, sir.
Say, Manish, the answer.
Sir, because large number of tiny pores is present on the surface of earthen pot.
Okay.
The water stored in the earthen pot evaporate faster to these pores due to increased exposed surface area.
Okay, fine. Okay, correct, Manish. Next. Okay, fine, good. Students, you will complete this assignment now only during the online class, and I will allow you at the end to switch on your videos to show me your classwork. So very good, students, you have shown your work. Yes, you have completed your work and you have shown your work to me also. Now, at last, okay, students, even you can take the screenshot of this slide so that it is a sort of quick revision for the different states of matter based on the properties. Okay, it showing you near about 14 properties and the different states of the matter, what features they are showing over here. Just a minute. Now, student, one also very important thing regarding in this chapter was the interconversion of the different states of matter, the scales of measuring the temperature, because some of the numericals also come over here, that where the temperature is given in Celsius scale and you have to convert it into Kelvin. Okay, so you have to remember 0 degree centigrade. That is in the Kelvin scale, if we are converting, then we have to add it 0 degree centigrade equals to 273 Kelvin. Okay, fine. Okay, definitely, students. Now our class is about to end, and you will revise this chapter. Okay. There is no written assignment I'm giving you today, but you will do the revision of the taught portions. Okay. So thank you, students, for today's class.